welcome to this explainer. All right, let's just dive right in, because we're starting with a scenario that, honestly, sounds a little terrifying. Picture this, okay? You're a communications instructor, and Penn State University just asked you to teach a class. But you aren't teaching humanities students or arts majors, no. You are walking into a room full of brilliant, highly technical engineering students. I mean, imagine the sheer panic. You're staring down a room of students with these incredibly big brains, carrying massive heavy books, and speaking using very large, deeply unfamiliar words. It's completely intimidating. But as those initial classes progressed and the conversations actually started to unfold, something truly magical happened. The terror faded and a totally different feeling took over. Come to find out, right behind all those big words and massive textbooks, these engineering and science students possess this beautiful wonderland of fascinating ideas. They were exploring concepts and building solutions that were just absolutely mesmerizing. The instructor realized that these highly technical minds aren't just calculating numbers, right? They're imagining entirely new worlds. And the absolutely crucial point here is that the rest of us, the non-scientists, the general public, we desperately need to see this wonderland. We literally need to experience the sheer awe of what they're discovering.
So, that brings up a massive question. Why does this matter? Why do we need access to this scientific wonderland? Well, the stakes could not possibly be higher. Right now, it's our scientists and our engineers who are stepping up to tackle humanity's absolute grandest challenges. We're talking about the future of our energy, preserving our environment, and advancing our healthcare systems. I mean, these are the people building our survival and our future. But here's the catch. If we, the general public, don't understand their work, then their work is kind of incomplete. We have a responsibility to engage with them for sure, but they also have to invite us in. Because if they don't let us see their wonderland, those world-changing conversations simply can't happen. And that brings us to the ultimate key to unlocking that door: effective communication. It's the bridge between a brilliant idea in a lab and a real-world impact.
Section 1. The Door to Wonderland.
Section 2. Answering the so what. So, when you're standing in front of an audience, you have to answer this one fundamental, unspoken question that is literally echoing in everyone's mind. So what? You absolutely must explicitly tell your audience why your science is relevant to their everyday lives. Like, if you stand up and just say, I study trabeculae, well, most of your audience is immediately lost. Their eyes glaze over. But if you say, I study trabeculae, which look like the mesh structure of our bones, to understand and treat osteoporosis, everything changes. Notice what happened there? You didn't abandon your science, you just anchored an incredibly complex anatomical term directly to a real-world outcome. Suddenly your audience cares, because, almost everyone knows someone affected by osteoporosis. You've instantly created relevance and deep engagement.
Section 3. Dropping the jargon. When you're passionately explaining your scientific specialty, specialized jargon is a massive, massive trap. It acts like this thick, impenetrable wall, keeping people locked out of understanding your brilliant ideas. And frankly, you don't need these heavy words to sound smart. Like, a scientist might naturally write spatial and temporal in an academic paper, but when speaking to the rest of us, why not just say space and time? It's a simple, elegant word swap that removes the barrier entirely. It's a concept we immediately grasp, and it doesn't change the fundamental underlying meaning of your scientific concept one bit.
Now, at this point, technical experts often get a little nervous. They worry that by dropping the jargon, they're somehow destroying or, dumbing down their hard-earned science. But look at this incredible piece of wisdom from Albert Einstein. Make everything as simple as possible, but no simpler. Making your ideas accessible is absolutely not the same thing as dumbing them down. You can be crystal clear and highly precise without compromising the integrity of your ideas.
To actually achieve that Einstein level of clarity, you need the right tools. You can make the complex simple by using narrative techniques. We're talking about relying on relatable examples, crafting engaging stories, and building really clever analogies. And listen, these aren't just fluff. They're incredibly powerful cognitive tools. They're the exact methods that draw an audience in, keep them completely excited, and help them deeply connect to the very core of your scientific content.
Section 4. Killing the bullet points.
Okay, we need to talk about the absolute most dangerous, destructive tool in a presenter's entire arsenal. Have you ever wondered why they're called bullet points? Because they literally kill your presentation. When you project a dense list of text to your audience, you're heavily overtaxing the language center of their brain. You're causing them immense suffering and draining their attention by the second. It's incredibly boring, and honestly, it makes it completely impossible for them to appreciate your wonderland.
Thankfully, there is a brilliant alternative pioneered by experts like Genevieve Brown. Instead of those deadly bullets, try this. Pair one single, highly readable sentence with a deeply striking visual. For example, if you're talking about that bone mesh structure we mentioned earlier, show an image of the unique bone structure side by side with the Eiffel Tower. Why? Because the bone strength actually inspired the Eiffel Tower's unique design. That one sentence gives the audience an anchor if they get lost, while the powerful visual engages their other senses. It creates a much deeper, far more memorable understanding than a list of text ever could.
Section 5. The ultimate communication equation. Okay, so we've covered answering the so what, dropping the jargon, telling stories, and killing the bullet points. Let's wrap all of these lessons up into a language that engineers and scientists speak fluently, a mathematical equation. Let's just walk through this incredible formula together, step by step. Step 1, take your science, your amazing, world-changing work. Step 2, subtract the bullet points and the jargon. Basically, remove the barriers that keep us out. Step 3, divide it by relevance, meaning share and distribute the parts of your work that directly connect to the lives of your audience. And finally, step 4, multiply it all by your passion for the amazing work you do. When you execute this equation, the results, it equals incredible, mind-opening interactions full of true understanding.
So, the crucial takeaway for all the scientists, the engineers, and the great technical minds out there is this. Step up, use this equation, and bravely share your wonderland with the rest of us. We genuinely need your solutions, and we need your passion. Talk nerdy to us. But this leaves us with one final, really powerful question to ponder as we wrap up this explainer. What grand, world-saving challenges could we finally overcome if every brilliant technical expert in the world successfully opened the door to their wonderland today? Think about that for a second. Keep learning, keep explaining, and I'll see you next time.